Hello everyone and welcome to Java Basics. Last time we enhanced our Wordle game, but it still doesn't remember where we were the last time around. This time we'll fix that. We will save the application state and load it. This is the code from the last video, which is our starting point. Today's code is in this URL. It too is in the video description, so you don't need to copy that either. Last time, we read from a file. This time, we'll try to write to a different file. First, we would want to write the date and time of the solution. It's common in programming to use a timestamp, which is simpler. In Java, it's common to use the current time millis API, which returns a number of milliseconds since epoch, which is midnight of January 1st, 1970 at the UTC time zone. You can convert this to a user-readable time easily. Notice that time is a complex subject as it varies based on location and season. Daylight saving is a source of numerous bugs. Next, we need to know the actual word of the day. Since this would change every day, we need to write that down in the file we save. We need to know the attempts that were made at guessing the word too. That way we can show the current state of the guesses when rerunning the app. We can also produce interesting statistics and insights. Let's go into the code and see how we can write and read all of this. First, we need to think where we can write the result to the file. There are two places where we return from the method, so we can write the file in both places. The right thing to do would be to invoke another method instead of copying and pasting the right code between both points. This is a core concept in computer programming called DRY, which stands for Don't Repeat Yourself. Try to write code only once. Next, we need to start collecting the words the user types in. Up until now, we didn't keep them anywhere in memory. We could use an array, but we don't know how many words we'll have. So we can use a list of strings. We already did some of those, so this code should be relatively familiar. Now we need to add the word in the methods. Specifically, the successful word, which we can then use to determine if the user guessed correctly in this day. We type in the name of the words list and add the current line matching the given word. Next, we need to scroll further down to the failed attempts and log them. Notice that even though this code is below, it will always execute before the successful attempt above. We type the word again. Notice that I do repeat myself a bit here, but it's one method call, so it isn't a big deal. Now we need to actually write the file. We create a new method called finishGame, in which we will open a writer object. This is the equivalent of the reader object we used the last time around. It's important to close writers as well, so we will perform this within a try with resources. So the writer will be closed for us implicitly. We give it a simple file name, state.txt. Notice that we pass true as the last argument. This is the appended flag. By default, a writer will overwrite the existing file and replace whatever is inside it. This means the file will be appended and everything we write will be added to the end. Since the writing code can throw an IO exception, we need to declare that we're throwing it. The IDE adds that automatically for us when pressing Alt-Enter. So the next thing is writing the text to the file. We write the time using the current time millis method. We use a comma to separate the values for each entry and add the word matching this entry. Next, we loop over all the words that the user entered and write each one with a comma before it. Finally, we finish writing the line with a single new line. But there's a better way to write this exact same code. We can implement the entire code with a single write method. We break a new line, which is fine. This is all part of the same statement thanks to the semicolon that's at the end of the actual statement. We can use the string join method and provide it with a delimiter, which in our case is a comma character. We have a missing plus sign we need to add here. And now we have one final big problem to solve. The code that we want to replace is a return statement. That won't work here. We need both a method call and a return statement so the application will exit. Luckily, we can remove the return completely. Java has a system.exit API call that lets us exit the application entirely. With that, we can now scroll up and update the return statement to invoke finish game. We replace all the return statements in the code with the finish game calls. These will exit implicitly, so we no longer need a return call. The next thing we need to do is implement the reading logic. For this, we need to add a new line and need to declare the file object that we'll be reading. In this case, the state.txt file. We previously used a file object in the dictionary loading just below this code. We need it since the first time we ran the project, the file might not exist. So we need to first check if the file exists to avoid an error. Notice we declare the list of loaded status strings outside of the if statement. This is important. If we have a file, then we can read it with code similar to the one we used to load the dictionary. That's simple enough. If we don't have anything, we can create an empty list. This will help the following code work even if we don't have a file yet. We can now place a breakpoint and run. Notice that if I hadn't declared the status variable outside of the if block, we wouldn't have been able to access it in the method scope. Once we do that, we can inspect the loaded file. I ran this before and I already have a file there. As you can see, we can look at the bottom right and see the results of that run. This is cool, but also a bit problematic. How do we read something like that and work with it? We will discuss this in the next video and also get into why we need object-oriented to do that. If you have any questions, please use the comment section. Thank you.